Welcome to the Anomalous Review. This is the official podcast of the Scientific Coalition for UAP Studies, or SCU. I'm your host, Michael Glosson. I'm a philosopher of science and technology and a contributing member of SCU. Our organization exists to further the serious technical study of unidentified anomalous phenomena, or UAP, and we're glad to have you listening. My guest today is Dr. Matthew Szydagis. Matt is an astrophysicist, and like most people doing rigorous work on the subject of UAP, anomalous phenomena aren't Matt's only area of interest. Currently, Matt is Associate Professor of Physics at the University of Albany, where he conducts experimental research in astroparticle physics. A lot of that work is geared toward designing machines and experiments for detecting the elusive dark matter that astronomers think might be responsible for holding our galaxies together. Matt's been working on UAP in his spare time for quite a while. He's a member of UAPx and the Scientific Coalition for UAP Studies. Matt's also a science consultant for shows that often discuss UAP, and there, in as much as he can, he acts as a corrective to the much goofier and less rigorous voices that are often featured in popular entertainment that deals with UAP. Currently, he's working with the Disney Plus show The Proof Is Out There. You might also have seen Matt in the UAP documentary A Tear in the Sky, which we discuss a bit in this conversation. Matt is also a frequent collaborator with Kevin Knuth, who also teaches at the University of Albany and who's one of my favorite interviews of all time. If you haven't seen that interview with Kevin, you should definitely queue it up when you're done with this one. Now, everyone, no matter their perspective on the issue, knows that the vast majority of UAP sightings can be explained as prosaic objects like Venus or terrestrial aircraft or satellites or meteorites and so on. This leaves a few percent of UAP sightings, though, that resist any prosaic explanation. We can think of these as truly anomalous UAP. If we zoom in on this set of truly anomalous UAP, we find first that there are many thousands of these sightings that can't be explained in a mundane way. Second, we find that there's an extraordinary variety among them, from location to the type of object sighted to the number of people who witnessed the event to the specific conditions of the encounter. Several different groups have undertaken the work of analyzing these accounts into a set of data points and compiling them into databases so that researchers can perform scientifically rigorous analyses of them. SCU, the organization that hosts this podcast, has produced a research report that looks at over 300 such cases. I discussed that report in our next episode with Robert Powell. A third consistent feature of these reports, however, is the frustratingly consistent fact that they're almost, without exception, all accidental observations. People don't witness UAP because they were looking for them. People happen to observe UAP while they're chatting outside at a cookout, or driving home from soccer practice, or while they're flying an airplane for their job. Obviously, this isn't the ideal way of collecting data if you want to do a serious analysis of it later. Ideally, you'd want to be able to plan your observations ahead of time, bring special equipment, focus on the task of observation. And you'd want to do this not just once, but over and over, so that you could build a robust data set. But who in the world, with the right equipment and the right scientific expertise, actually goes out looking for UAP? At least that was the answer until 2021. That's when the group UAPx was formed, by a collection of physicists, engineers, and former and current military contractors. UAPx is working to address this problem of purely accidental data collection by going out and actively observing UAP using a wide variety of sensors and modes of observation. My guest today, Matthew Szydagis, is one of the members of UAPx. We discuss UAPx's first research expedition to Catalina Island off the southern coast of California, and the results that they obtained from that project, which may have been a first of its kind. We also got to talk about Matt's research on dark matter, where I probably annoyed him with some of my philosophical skepticism about the very idea of dark matter, but we round out the conversation by talking about our favorite ideas from science fiction. I think you'll really enjoy this episode, so here now is my conversation with Dr. Matthew Szydagis. Welcome to the Anomalous Review, the official podcast of the Scientific Coalition of UAP Studies. My name is Michael Glosson. I'm a philosopher of science and technology, and I'm the host. And today, our guest is Matthew Szydagis. He is a professor of physics at the University of Albany and a regular on the History Channel's The Proof is Out There. Matthew, welcome to the show.
It's great to be here.
Yeah. So the very first thing that I wanted to ask about is the organization that you are like a pretty long time, maybe founding member of. I don't know, UAPx, right?
That's right.
What is
Um,
what is UAPx and what do you do?
so UAPX is an organization that is focused on getting data on UAP, not reanalysis of old cases. So while there are similar organizations, most UAP or UFO organizations, most of them are very different from UAPX because they're focused on reanalysis or meta-analysis of historical cases, which is very valuable, but is probably part of a larger whole. So UAPX has a different approach, which is to go get our own data on UAP. And I'm a member actually not just of UAPX, but also of SCU, for which this podcast. I've actually was a member of SCU first. You asked if I was a founding member of UAPX. Not quite, but close. I was recruited very early on in its existence.
By Kevin Knuth?
That's right, by Kevin Knuth, who was in turn recruited by Kevin Day. So UAPX was co-founded by U.S. Navy veterans Kevin Day and Gary Voorhees, who are both Nimitz/Princeton Tic Tac encounter witnesses. They're not the pilots, like Fravor and Dietrich, but they were they had other roles on the ships in the carrier strike group.
Like radar and sensors and things like that, right?
Yeah, exactly. I think Kevin Day was on radar, and Gary was one of the firemen, which means weapons control.
So they were part of this encounter, and I sense felt a lot of frustration that it wasn't taken so seriously, or maybe that it was taken seriously, but it wasn't like publicly acknowledged and handled in the way that they think that this sort of information should be. So they started their own organization specifically with the aim of collecting entirely new measurements and data on UAP. Is there any other organization prior to this or much prior to this that was doing something like that? Or is this a pretty new kind of project?
So if you look at the history of ufology or UAP studies or whatever you'd like to call it, this has happened before, but it wasn't that common. So there have been attempts like this before to do, field expeditions to UFO hotspots or alleged hotspots. So it's not an entirely new idea, but UAPX was one of the first newer organizations founded in sort of the post Leslie Kean and Lou Elizondo era, after the existence of ATIP was revealed by the New York Times in I believe it was 2017. So it's one of the newer organizations. And older efforts, like there's Professor Rutledge of Southeastern Missouri University in the 70s. There are a lot of these older efforts, but the older efforts suffered from the stigma against the topic that was much stronger in the past than it has been recently. As a result, a lot of the older field expedition efforts were unable to publish their results in a peer-reviewed high-impact scientific journal. Some of them published their results in journals that are not considered scientific enough by the mainstream community, or they wrote up their results in books. And books are great, except that anyone can write anything in a book.
There's no peer review for books.
Exactly. Exactly. So UAPX is not the first, but is one of the first of the new cohort in the new era after the big reveals of the ATIP program and the Navy videos like the Tic Tac and the Go Fast and the Gimbal.
So it seems like that makes you the first in a sense, at least qualitatively. Like if the last projects that were really doing this in a systematic scientific way were in the 70s, I mean the technology gap between now and then is just vast. So you're not just getting incrementally better data, you're getting entire qualitatively new kinds of data. You probably have qualitatively new analytic methods that you can use on that data. And you're now in a position where you can publish these for peer review, and you've got like a sufficient amount of interest among the qualified scientific community that they can actually do review on it and are willing to do review on it. So that seems like you're the first of a lot of things at UAPx trying to go out and actually get your new data. And it seems like the data that so you made the distinction between UAPx, which is seeking to generate new data observationally, and other organizations that are looking at sort of doing metadata analysis on case studies that already exist. But it's not like those organizations are looking at the exact same kind of data, because most UAP observations aren't made using anything like the methods and systems that UAPx does. So you're not just trying to like add to an already existing pile, you're creating an entirely different pile from
That's right.
people just looking up and seeing something in the sky, which is a great UAP report. I mean, if 50 people in clear observational conditions see the exact same thing, that is great high quality evidence. But it's very different from what you guys are doing. So tell us, what is it exactly that you're doing? Like, what's your setup? You went on this expedition. I read your I think it's like 40 something page first UAP field expedition report. It was published a few years ago. It's a fantastic piece. It's very detailed. But without requiring the listeners to to spend the time of going through the 40 pages, take us through, like, what's the setup that you're using when you go out and observe, and where did you take it?
No, we had visible light cameras. We also had infrared, and we had a lot of other sensors. We had a radiation detector. We had more than one detector, actually, of ionizing radiation. Those are the major sensors. We wanted to do more, but as usual, especially when you're doing something the first time, your plans sometimes exceed what you're able to actually implement because of person power and just technical difficulty. So we don't really have magnetic field detections was one thing we'd like to add. So we did a lot of night vision goggle measurements. Some team members were able to do that. That's a different spectrum than FLIR cameras, for example. But there they don't actually record, so we have to do it, like in the style of like Jeremy Corbell, people like
Sure.
smartphone up to the
Yeah.
binoculars. We could still get stuff that way. So we were not at the high ideal that we hold ourselves to in our first expedition, but it was a really good trial, a run where we went to Laguna Beach, California. We also had a
Why
team
there?
so why there? So that we could view the Catalina channel. So we also had a team on Avalon and Catalina Island. The idea was to revisit the location of the Nimitz encounter. So that was Kevin Day's and Gary Paris's idea. And that, of course, the criticism always is, well, that was, 2 decades earlier. What, are the Tic Tacs just hanging around? But really, that's not the only motivation. Because if you go back and just look at just websites and newspaper articles about Catalina Island and the Catalina area, sort of in between and near both Los Angeles as well as San Diego, that's supposedly a hotspot, completely separate, like before we even knew about the Nimitz encounter. That was 2004, but it wasn't really made public in a major way until 2017 with the
Because of the
public.
encounter, right? There was that one high profile encounter, and then it becomes
In
public.
2004,
But it had been known since then.
but it's been since before 2004. There are stories going back to the 1970s about alleged encounters with UAPs and USOs, unidentified submersible objects, also in the Catalina Channel. And so that's why it was a decent place for a selection of a first expedition.
I think it's interesting. This demonstrates how, with all empirical science, there's kind of a gradient between everyday individuals' observations and experience of the world and the really rigorous scientific study of it, where like you can't do this latter thing without, in some sense, starting with and being informed by people's everyday observations. Like when we discover new species, like the colossal squid or something, we don't know how to study that other than by listening to people who are like, yes, I was on a boat and I saw one of these things out right there. So where do you go? We don't know enough about the thing to have an a priori or, well-formed idea yet of where they might go. So we just rely on observations and we set up and see what we can see. So that's sort of what you're doing. You're taking this history of observational reports, some of which are well documented using military equipment and military observers, and you're setting up. But it seemed like a really good location for other reasons too. Like you get this interesting, nice observational vantage points. You have these two vantage points because you got a channel running from, you got California's coast, and you've got this channel, and then you've got the Catalina Island, and you had observers on both sides of it, and it's in that channel that is that where the Nimitz encountered the object was within the channel or just around the area?
Well, we don't know for sure, I think, because, the
Oh,
exact
sure.
training area is probably classified, but it's somewhere around there. Might have been further out, though, Pacific. But yeah, we don't. It's funny that you mentioned one example. I'll give you another, which is meteors. People for thousands of years are saying rocks fall
Yeah,
from the
rocks
sky.
don't fall from the sky.
Yeah, rocks don't fall from the sky. They were laughed at, they were insulted, and the same thing's happening again. History repeats itself. So our philosophy on UAPx and other groups take a similar philosophy, like the Galileo Project, which is to not, you don't, we don't discard eyewitness testimony as, useless because it's unreliable. We have instead a middle of the road approach between, oh, you just believe any crazy thing people tell you versus throw all of it out. Our approach is use the eyewitness testimony of past encounters to inform what type of sensors you want to use, to inform the scientific plan for a scientific expedition. So it's kind of like it's an approach where you don't count eyewitness testimony as evidence or proof of anything exotic, but you use it partially. You use it as motivation for what might be good things to look for. So I mentioned, magnetic fields that we didn't measure in the first expedition, but wanted to, so didn't get the sensors working. Where did that come from? It comes from, stories of UFOs shutting off cars and stuff like that. So even the crazy stories that we may or may not believe fully can motivate what we do in a scientific expedition.
Yeah, and that term belief isn't even really the right thing for people to insert into the scientific process. It's like, we don't know if we believe this happened or not. We're trying to figure out if we should believe it or not by putting some sensors there and seeing if we can actually confirm, or you can't really disconfirm it, but if you could get corroborating evidence at least. So you've got this, when you go out on this expedition, you've got all these sensors. You're seeing, it sounds like you're saying, you can see the visible light spectrum, you can see the infrared spectrum and FLIR, and then another part of the infrared spectrum that you see through night vision goggles, but those weren't being recorded. So you've got those sorts of cameras, and you've got like an array of them so that you can see some portion of the night sky. How much of the sky could you see at one time?
Oh, that's an excellent question. I don't know, and that's not in our paper, actually. It was definitely less than 50% because we're all pointed in one direction and we're not seeing overhead or behind us. And so I would say it's definitely less than 50%. But I think that despite that, I think we actually had too many cameras. And I mentioned this in the paper because when you collect too much data, especially when you've got cameras that are, maybe older models, might have some camera noise, glitches, camera artifacts, it makes the data very hard to analyze. So actually going forward, we actually want to have fewer cameras and higher quality. That, of course, then runs the risk of like, oh, the UFO is over there. And we want to try to balance that in the future by doing a better job of having, for example, one or two, fisheye cameras that see the entire sky, and then have other cameras that can swing to see where that camera, the larger field of view, has seen a detection. So we're refining our methods, especially given the lessons learned from the first expedition.
So that refinement that you just mentioned, having like one fisheye lens and then a bunch of other higher quality cameras, the idea then is that your fisheye camera is surveying the entire sky, but not really at the right, it's not at a smooth, consistent resolution, right? There's some distortion, but its purpose is to see if there's anything moving or weird at all. And then those other cameras will then arrange themselves to look at it. So the first one is like movement or odd or shape detection or something, shadow detection, and the others are the thing that are really getting the high quality data that you want to look at.
Exactly. So for example, you have a camera that has a wide angle, but then because it's seeing so much, an object will just be a dot, but then the other camera finds that same dot and like, oh, that's an airplane. Those are things. We did a little bit of that, but not enough of that. So we did have a dual camera system that would sometimes ride on top of the roof of the Osiris from Jeremy McGowan, this famous UFO hunting, car. It's kind of like I've given Jeremy the compliment of the Osiris kind of being like the it's like Ecto one from it's from the Ghostbusters, but for UFOs.
Yes.
So sometimes there would dual camera system right on top, but most of the time, unfortunately, we split the camera system. We just didn't have enough cameras for visible light. We had
Mhm.
more than their cameras, and so we'd have a fisheye on the truck and then the pan tilt zoom camera on the roof. So that defeats the purpose of what I was just saying. So again, lessons learned about what we could have done differently, we could have done better. You mentioned earlier about the 2 points of view. We were talking up triangulation. We didn't end up triangulating anything pretty much because in order for that to work, you need to have two people seeing the same object and be sure it's the same object. And how are you sure of that? From both perspectives. So again, we didn't get to do any of the type of triangulation we really wanted to do. We did some, but it required using things like reference points of like estimating the cloud ceiling and stuff like that. But we weren't able to get the kind we actually wanted, where there's a UFO in the channel and we could see it simultaneously from the island and the mainland.
And that doing triangulation in real time like that is a pretty gnarly skill too. I mean, you have to be really good at estimating the distance and like how many arc seconds the thing is above the horizon, and that's just not a skill that most people have, even if they have a really good pair of binoculars.
Yeah,
So,
I don't think we were ever intending, maybe we were intending at one point, we were ever intending on doing that live. But after the fact, we could always go back,
oh,
ideally, and look at images, look at videos. And if we knew the metadata and knew where people were located with those cameras, then we would be able to do that carefully and slowly, not just a quick and dirty estimate in the moment.
so would you set up like beacons or reference points also in the future that you could use as like calibrating sort of information between cameras?
Absolutely. We did a little bit of that. It's not really in the movie A Tear in the Sky by director producer Carolyn Corey, but there were some deleted scenes I know where Jeremy and the Osiris was using like a laser to calibrate the dual camera fisheye PTZ system via UFO depth. So yeah, no, calibrations are extremely important, and one of our ideas for doing that is actually in the future deploying simultaneously or maybe serially at not just a UFO hotspot, but like a non-hotspot, an area that like has never reported a single UFO, so that
Yeah.
you can have control data. And you need to have at least two kinds of control data, like a completely quiet rural area with no airplanes or UFOs, and then like next to a bustling airport, for example, to get a lot of planes, get a lot of birds as well, things like that. So we're looking at trying to take control data along both positive and negative axes in the future.
What happens if you run into the problem that like researchers have where like you just can't find a spot that doesn't have some sort of activity in it? Does that just screw up the future of uh, UFO research?
I'm skeptical that that's the case. I'm sure there are still areas that have at least that are low in human airplanes, as well as don't have let's say an above average number of UFO
Oh, sure.
reports.
Yeah, at least
I'd be
needs to be low.
shocked that such a place doesn't exist. I'm sure it does. I mean, we're already looking at places locally in New York State, close to the University of Albany, where we're looking for potential hotspots, but also looking for areas where, like, the last interesting UFO report is like from the 70s or
Hmm.
something, so it's a good
Yeah.
controlled area. So no, I think that it's definitely still possible. If you're worried about satellites, of course, there'll always still be satellite guys much more cluttered today than it used to be. But there is a way to counter that. There are apps. You can look at where's Starlink right now, where's the ISS right now. So while yes, no matter where you go on Earth, it's true you're going to get satellite. You can't avoid that. So, but that you can at least check against apps, against smartphone apps that track rocket launches, that track Starlink launches, and things like that.
And there's like the FAA's flight map and all that
Yeah,
that you can pull from too.
yeah,
And you were pulling from some of these sources while you were doing the expedition, right? So you have all these cameras and
correct.
observers out there, but you're also comparing what you're observing to like what are those sources? Like I know the FAA is one of them. What are the other things that you're looking at to see like, oh, that's probably Starlink or whatever it is?
Yeah, so there are plenty of astronomy apps you can get on on iPhone, on Android, things like that won't just list astronomical objects, they'll list satellites. They're not gonna list planes and helicopters, but they'll take care of satellites. And they'll take care of rockets. They'll take care of artificial objects. Not all apps, but some of the apps do that, or it's a layer that you can turn on. And so, yeah, it's just planes are not enough. Of course, FAA and ADS-B are only part of the equation. You also need to take care of the stuff that, outside the atmosphere.
Can anybody look at like that FAA map and see if something above them is a plane or?
Yes, I know there are websites like FlightAware where you can do this, and you can see like these nice colored maps of where all the planes are that are broadcasting their transponder signal. I don't know how easy it is to go back in time and get historical records, but it's not too difficult to do this live. And even, it's not just planes, helicopters at the Firefly pans. So like during the movie A Tear in the Sky, we had like a helicopter pass by where they veered off of their flight path, probably because they saw, wow, what's all that equipment on that rooftop doing there? So, I don't know, corporate espionage or something.
Yeah, the cops come too, right? Didn't the police come and ask you about what you're doing?
Oh yeah, because it's the Los Angeles area, nosy neighbors, right, who have nothing better to do than to complain. And so somebody complained about us, like,
oh, really, literally
on a roof hurting anybody? We were not noisy. It's not like we were partying. We were pretty quiet most of the time.
So, I'd be suspicious if I looked out my window and there was a whole camera crew sitting on top of a building. I might just ask them myself too. I don't think I'd call the cops, but it'd be
but in the California area, I would just assume
everything's a movie, right? You're in a movie every moment there.
Exactly, but the neighbors didn't like having a movie being filmed actually in there.
But you didn't have to leave, did you?
No, well, I can't for the record since we're recording. I can't tell you how we solved that, but maybe off the record.
Oh, I would love to.
How we fixed it later. It wasn't the police that came by. That was only stage one. Then stage two is then a different, like, not police, some other like office with agents came to see if we had a filming license.
Interesting. Oh, okay. So like
it was a multi-stage process. But yeah, once we put them on the scissor lift and brought them up to see the setup, they thought it was really cool, and nobody wanted to bother us anymore after seeing the setup, pretty much.
So that's the key. You need to always bring a scissor lift with you and just offer people rides. Like, oh, this will be fun. Just get on the scissor lift. You won't be mad.
No, the scissor lift wasn't the exciting thing. It was taking it to the roof and seeing our equipment.
Oh, okay. Yeah, there's your setup that they
would see our equipment and be just like impressed and not want to kick us out.
And you told them what you were looking for, right? Like, we're looking for UFOs.
Honestly, I don't remember. This was 3 years ago now.
Yeah.
I stayed out of it when, like, if cops showed up or the filming, I'm like, well, we'll let Carolyn take care of it, or one of the other the film crew people. And so I don't know what they said. Maybe, I think at one point I overheard that they told them we were doing a meteorological thing. So I don't think we admitted UFO necessarily. I think it depends who was asking.
That's funny. Little like social engineering skills for the UAP community.
That's right.
Okay.
Yeah.
So tell me about the UFO DAP. What's a UFO DAP? It's a tool you used.
It's a camera system it's a commercial camera system, but with other tools like sensors and software added to it by a California engineer, retired engineer, Ron Olch. So it's one of the available systems you can buy for UFO hunting. So he didn't design the camera. It's like a commercial, like black, security dome, camera. But Ron's been adding stuff to it, like more sensors, software.
Is this something that a hobbyist member of the public could invest in and have any use for, or is this a really fancy tool that only is used by scientists?
That's a great question. I think that at a cost of several $1,000s, I don't know how many hobbyists will be able to get one. I do know many who have, but yeah, I think operation of the software would be a significant challenge, unfortunately, for the non-scientist, non-engineer. So I can't exactly recommend it in that way.
But it was useful for you.
It was. It captured our most interesting ambiguous event.
We'll get to that in a minute. I want to hear the less exciting two questions I have before that are tell me about like the actual camera's digital information situation. Like, do you know what the frames per second rate on the cameras were, or whether you used any sort of compression at all?
Yes, it's all in the paper. So it depended on the camera model. Some were 20 or 30 and some 60. I don't remember which was which, but it's all documented in writing of like the FLIR and the UFODAP, of course, all had, well-known frame rates and resolutions,
You
which of
mentioned the
course,
specific models of cameras too. So like you give a very detailed, people can
yes,
look this up.
we're very detailed because we want to be scientific. We don't want to just say, oh, we went out with some cameras. Well, what kinds of cameras? What? Because we want to allow people to be able to, Google that camera model
Mhm.
and find, well, what are the strengths and the weaknesses of that camera, so that everything is open. So we share our knowledge openly with everybody. So we know the frame rates, we know the resolutions, and when we were doing analysis of the results, we would actually pull out the the full uncompressed images frame by frame from the videos. So the information is temporarily compressed, but we can recover the original resolution images, pulling them out of the video files, the MP4s and the AVIs and the different, standard video extensions. We're able to pull out full resolution bitmaps frame by frame when doing our image analysis.
So for people who aren't, super attuned to the world of like digital video compression, uh, I can imagine somebody feeling a little anxiety at hearing that, oh, they were temporarily compressed. But the way compression works is that there are lossless and lossy versions of compression. And so
Yes.
when your cameras are recording, they're quote compressing. Most people, I think, hear compression and they think that that means that there's necessarily some sort of loss of image quality or data. And that's not the case.
No, that's
So,
not the case. That is often the case with a lot of UFO videos. That did not happen to us, where what happens is if you post your videos online, then they're downloaded, and then someone reposts, then it may turn into a game of telephone with multiple stages of lossy compression. We did not do that. And to make sure that that doesn't happen, we have multiple copies of the original data so that if something happens, we all have copies of the original data from the cameras before we started messing with any files and doing any analyses on them, so that we can avoid this game of telephone of multiple stages of decompressing and recompressing that often happens when people post UFO videos to YouTube and things like that, and then they're downloaded by somebody else from YouTube, and then it's not the original anymore. We do our best to avoid those types of situations on UAPx.
and there's no so we're not seeing a copy of a copy of a copy of a copy or
No,
whatever. And
no, no.
there's and the way that your compression is working is it's not the sort of codec as a compression and decompression program that makes any sort of guesses. Like it's not like it subtracts 50% of the pixels and then when it decompresses it, it just makes a guess as to what was in those pixels it subtracts. You're getting exactly the data that you
Well,
were.
as far as I know, that's not the case. That being said, there were still weaknesses. So, for example, on the FLIR, we have data, we have the raw data, but it's not the full raw that we would have liked. So it's not like the temperatures or intensities of infrared photons in the FLIR. It's the color that was created by the FLIR software. So there is one step there where we could have gone one level deeper. So again, it wasn't perfect, but when we analyze data, we never go off of like a low resolution version of a clip. We always, if we're doing analysis, always check back to the original data that we saved multiple copies of immediately during that.
So you're in the case you just gave of the FLIR film, what's being saved is exactly the heat map bitmap that was produced moment to moment. But what's not being saved are the precise numerical temperature values of each of those
That's
pixels,
right.
which would create an enormous file and could be useful, but all it would ever really produce probably is the exact lossless bitmap of FLIR image that you got. So that's not a compression or like lossiness issue. That's just saying we could have stored way more information, but we're not sure we would have used it in any productive way. So maybe in the future we will.
Well, we could have. It would have been beneficial, but we just didn't have that with the models we had and the software we had. But yeah, so what I'm talking about is the step between translating from temperature into a color scale, that we don't have that step but we do document the model number of the FLIR's cameras that we use, as well as what reporters we use, so that anyone can dig deeper if they wish into our hardware and software chains.
So for like, so what you end up with is when you look at a FLIR image that you've recorded, you can zoom in on a particular pixel and you can see its color, and that color will specify a range of color temperature.
That's right. Exactly.
You know that whatever stream of light was hitting that sensor at the time is within that range, but you don't know its exact numerical value.
Exactly.
And
so there is some. That's right. There is some loss of information there, but it has nothing to do with video compression.
Yeah.
It just has to do with the conversion from temperatures into colors.
And so it doesn't mean that there's any possible error being introduced. It's just not as highly specific as you would.
Exactly. It's a difference of accuracy versus precision. To the best of my knowledge and that of my, I think, colleagues, that is a loss of precision, but not of accuracy.
From what I read in the paper, I don't see any loss of accuracy. I see only losses of degrees of precision, which
that's right.
is not
right. And it turns out we didn't get our most useful information from the FLIR anyway. We got some potential anomalies, but it's not where our most exciting, where most of our effort was devoted in the end.
Let's talk about the results. What sort of, first you use the term anomaly, but there's a conceptual distinction you make in the paper that I think is really important and that we should focus on a little bit first, between an anomaly and an ambiguity. What's the difference between those as you guys talk about it?
Well, qualitatively, the difference is you might not know what something is initially. And so it's ambiguous. Could it be weird? Could it be something exotic? Or could it be something identifiable? So technically, ambiguity is already a UAP because it's unidentified. Doesn't mean you've identified it as, spacecraft with exotic propulsion, right? But an anomaly is something where statistically you've shown that not only is something qualitatively strange, but in the paper we specifically refer to, we have a coincidence timing across different sensors, where you have different sensors all registering something above background. So for instance, what if you have a weird shape in the camera, but you also have a radiation detection? Because that wouldn't make sense, because no aircraft or spacecraft that we know of, or natural atmospheric phenomenon, should be producing ionizing radiation at any considerable distance. So to call something anomalous, we're trying to raise the standard in the paper to say that you need something across multiple sensors to be anomalous, and it needs to be statistically significant. That means that it's not just what's called in science an accidental coincidence, which means, to compare that to the connotation of the word coincidence, how it's used by non-scientists, an accidental coincidence just means coincidence. That means those two things are not related, but they just happen to occur at the same time because, let's say, you have two or more large volume data sets. And so there is some probability this data set has
always be, yeah.
Just exactly. Things that that's called accidental coincidence. And so if something's anomalous, we're saying you've got something that's significantly beyond the accidental coincidence probability. And there's still, unfortunately, we try to be quantitative, but there's still a qualitative dimension, because when you've got cameras involved, sure, you can have a cluster of pixels that's, definitely statistically significant, but it's an airplane or a bird. So there's also the qualitative dimension in the camera aspect of, is the camera image itself qualitatively ambiguous, at least initially.
So let's think of just a clear thought example to demonstrate this distinction between an ambiguity and an anomaly. So let's say you and I are standing on top of my building here, looking out at the ocean. I live in Charleston. The ocean's pretty close to us. And we've both got, let's say, we've got a FLIR camera and we've got a radar sensor, maybe. And we're looking at the information that we have between us. And I see something off in the distance with my eyes, and it's not clear what it is. It's a blur, right? At that point, we call that an ambiguity, right? Because a blurry spot in my own vision could be anything. It could be a swimmer in my eye. It could be a bird. It could be a cloud. It could be anything. Um, but if you and I look at, say, the FLIR image and we see something there too that's blurry, or maybe, it doesn't have to be blurry, but we see some object at the same place, you'd say, well, now we've got an anomaly because it's hard to imagine something that would spoof my own vision as a blur and then would also spoof the infrared in the same sort of way. Is that kind of the idea?
Well, almost. You're close because just because it's in your eyes and in the FLIR doesn't mean it's not an airplane
Right.
or a drone or a flying animal, right? A bird, like a bird. So, or insect. And so I think when we get to anomaly, we mentioned this in the paper, it's not enough to have a coincidence of multiple sensors and non-human sensors and account for the statistics of, two types of sensors having a hiccup or burp at the same time. There is another aspect to this, and that is what is the null hypothesis or null hypothesis? In other words, what are the mundane or prosaic explanations that are possible? The tricky thing here is that even though we try to be quantitatively rigorous in the paper, there's always still a room for non-quantitative interpretation because someone can always come in and claim you didn't systematically go through all possible null hypotheses because it's impossible. You'll forget the one type of, we tried to list in the paper, different explanations for UAP. You can never be comprehensive in saying what something is not because who's to say you didn't forget one on your list. But the important thing is to make a sincere, good faith effort across multiple scientists so people can peer review each other and help fill in gaps of things that people didn't think of. Oh, did you check this? Or did you check that? And so, yeah, we want to be cautious. So the example you gave, it's still not an anomaly. And it would be jumping to conclusions to call that example you gave an anomaly, because what stops the example you just said from being a distant airplane? You need to check things like the FAA records or look at live ADS-B tracking of transponder signals on the FlightAware website, things like that. You need to start eliminating possibilities. Like, let's say there are no wings. Okay, but what's the resolution of your eye or the camera? Would you even see wings as they would be there? So you have to address these things which are called systematics or systematic uncertainty. So it's not enough for something to be a statistical anomaly. You need to account for both the statistical and systematic sources of error.
So then let's go back to specify our example a little more. I said initially that we had both radar and FLIR because I was thinking maybe my first example wouldn't work out in the way I hoped. So let's go back and say you and I are looking out and we both see something. We're not sure what it is. And we check the radar and it is there. There's an object there hovering in the sky at some definite distance that seems to correspond with what we're seeing with our eyes. And we check the FLIR now, and we see that there is an object and it's really cold or really hot. And it's just sitting there, and we don't have any other object that we can think of that would behave in this sort of way. Now, do we have an anomaly, or is it still just an ambiguity?
We have to look at the numbers, basically. And in our paper, we emphasize how we need to have some sort of quantitative rigor and avoid qualitative distinctions whenever we can. As I said, we still can't avoid them entirely because different people have different lists of null hypotheses. But what we can do is look at the numbers. So let's take the example, we said it's very cold, so we want to identify what the probability of a random cold glitch in the FLIR happening at the same time as a glitch in the radar is probably going to be really low, especially if this is not just a one frame incident, right? If the radar is showing it consistently and the FLIR is showing it and it is staying, this is not just one or two camera frames or one or two sweeps of the radar, then we've almost certainly got an anomaly there, statistically speaking. But with the hot thing you said, there I would still be very hesitant to declare something an anomaly, even if statistically it's an anomaly, because everything's hot. That airplanes are hot from propulsion. Birds produce heat just like other animals, like mammals. And so if it's hot, I would not want to jump to anomaly yet. it would statistically be an anomaly already. But there's still that further distinction of, well, what are the sources of systematic error? And one of those is there is a mundane type of object. There is a null hypothesis that explains that observation. But if what you were saying was, if it was cold, cold is in the environment, and that is not normal or typical or common. And so if you have the radar saying you have an object and the FLIR showing an object and the object is cold, so we're stating 3, not 2 facts there, then depending on the probabilities of a glitch in the FLIR and a glitch in the radar at the same time frame, that is probably an anomaly. That is worth investigating and investing time and effort in getting even more data on to try to identify that. Because declaring something an anomaly does not identify it.
No, definitely not.
Identified it as an anomaly. That doesn't mean it's an alien spacecraft. Declaring something an anomaly just means it's worth your time and effort to go learn more about to try to identify it. It doesn't automatically identify it as an alien spacecraft.
No, absolutely not. And that's a sort of presumption that annoys the hell out of me when I came into this field initially, is that everybody assumes that what we're really talking about is alien spacecraft. And I'm like, I'm not sold on the ET hypothesis or the spacecraft idea at all. It seems, I guess, possible, but it doesn't seem like the most likely. I don't even know how to rank the likelihood of various different possibilities.
I favor that hypothesis. I do find it the most likely, but despite that fact, I still agree with you because it's a matter of principle. So to me, I think it's perfectly fine to entertain the extraterrestrial hypothesis and the possibility that some tiny fraction of UAP might legitimately be spacecraft operated by a non-human intelligence. I'm down with that. But as a matter of principle, I do agree with you that you cannot just take UFO or UAP, where U just means unidentified. And I am sick and tired of the wink, wink, nod, nod. Oh, we're talking about spacecraft when we say that. No, we might be, but it's not guaranteed. So we should stop making those terms equivalent. And it drives me absolutely crazy when those two are made equivalent. We could be talking about, what about ball lightning and earthquake lights and all kinds of very cool, very exotic natural phenomena that have nothing to do with aliens or interdimensional beings, and yet are worth studying, yet are worth investigating and finding answers for. So yeah, I love the extraterrestrial hypothesis, but I try not to let it cloud my judgment and make me take the word UFO and make it equal to alien spacecraft. I hate when people do that, especially when they start a conversation with me, assuming immediately that those two 100% equal and then launching off from there. And people just do that implicitly. That I'm talking to them, like, you just made those two equal without even telling me, without saying it, and you just forged it ahead.
Yeah, it's not a hypothesis for them. It's a presumption. It's
exactly. And I'm totally fine with it being a hypothesis. But let's stop making a presumption and stop pretending we're all agreed that all UFOs are aliens. We've got to stop doing that, because that invites additional ridicule and that increases the stigma that this investigation of the topic faces.
Yeah, totally. And I'm the thing that annoys me the most is this other neglected hypothesis that I favor, which is that these could be things that we don't even have a proper concept for yet. That they might be something there's no analog to. Like we think of them as, when we think of it as in the ETH, the extraterrestrial hypothesis, we tend to think of them as craft that are like analogous to, I don't know, the Starship Enterprise or a Tesla or something. It may be that that's the closest analog we have, but really it's nothing like it. It's as close to what it is as like thinking a bird is a plane or something. Like there's some things in common, but
maybe they're not metallic craft. What if some UAP are alive in some fashion, right? Literally. There could be ways that our categories might not even work.
Yeah. I often wonder, like, if there are inhabitants behind them. I mean, I sort of do presume that there's something like an intelligence behind this. Like, if you could just sit down with it and somehow establish communication reliably, and you ask like, are you an alien or what? I think my bet is that the most appropriate answer would be that like, yeah, we're sort of like an alien, we're sort of like a ghost or a god or a like I don't know, jinn or something like your language and culture and history have just not provided you with the set of concepts necessary to have this conversation. It's like trying to explain an iPhone to Aristotle or something, you know.
That's right. Or another example, I heard this one from Neil deGrasse Tyson. It would be like explaining to a chimpanzee who has learned, let's say, sign language,
Hmm.
okay? And trying to explain when a chimpanzee asks for a banana, oh, I don't have another banana right now, but we'll get another shipment in from South America. What's a shipment? What's South America? Like you're a chimpanzee,
Yeah.
you don't know what the hell those words mean. And I worry that you could be right. I hope you're wrong, but I worry you could be right that there could be intelligences involved where our neat little categories start to lose meaning.
That's what I'm betting on, but I don't. You say you hope not. Why do you hope not? Does that just
Because
discourage
I
you?
want to sit down and have a beer with an alien and ask them, do they believe in God? Do they have mathematics? Do they have the same type of science as we do? I would be saddened if what you said was correct because I feel like um, then communication might be more difficult. You see what I mean? If we can't even
Mhm.
share a common framework of viewing reality. I'm not saying you're wrong. Not at all. You could very well be right. Many people have made this case, Jacques Vallée, and many others have made the exact case that you're stating. But I'm still hoping for like a good old fashioned aliens that are just like sentient beings that evolved on another world. As long as, like I said, just don't when we're talking about UFOs, don't automatically equate the two. I'm all for doing a podcast interview where it's like, okay, we're going to talk about aliens and the possibility UFOs are aliens. No problem. Let's just state that up front. Not
Yeah,
make it a
yeah,
presumption. Like we're going to talk about UFOs, and then the next sentence is, so how do you think they build their ships? Where do they come from?
yeah. That is exactly what annoys me.
But some UFOs are probably like earthquake lights or ball lightning.
Yeah.
They don't build, nothing's building anything. It's a natural phenomenon. And so, yeah, I get aggravated when we kind of just throw all these different phenomena together and say it's all alien. It probably not. And we should not do that
Can't be.
conflation.
If it is, the world is just full of aliens. There's like way
I
more
know,
aliens
yeah.
than
I
we know.
really doubt there are that many aliens flying around our atmosphere. Again, I think a small percentage of UFOs could be aliens, but I don't like it when we take every single unexplained case, which is already a small percentage, and say all the unexplained cases, those must be aliens. I'm like, not
Yeah,
necessarily.
no.
Not even the ones that are like, 50,000 miles an hour on the radar. It could be a really, really weird atmospheric phenomenon we haven't understood yet that occurs in the Earth's atmosphere. Like,
It's a totally anti-scientific sort of way of thinking too, because it just shoves it off the table of exploration. Like, well, if it's aliens, you've already decided what it is, and there's no need to apply any sort of like rigorous analytic method to it other than trying to figure out what sort of engine they use, which is probably not the
exactly.
right question if it's
Yeah.
ball lightning.
Yeah, exactly. I get aggravated, when there's questions about what kind of engines they use before. I'm okay with discussing those questions. We can talk about, relativistic travel and warp drive as long as up front we say, look, I am assuming UFOs are aliens. As long as that's stated up front, we can continue the conversation from there. I just don't like it when occasionally it's implicit.
Yeah, you have to
And
know what hypothesis you're entertaining during the discussion. So you did get some, you didn't get any anomalies in the way that you were describing them, which if I put a quick and dirty definition down, it sounds like anomaly in this paper means when you have exhausted all of the possible explanations that are prosaic and you have enough information to know that which prosaic explanations might apply and none of
yeah,
them seem to work, you've
yeah,
still got a phenomenon. We'll call that an anomaly. You didn't
yeah.
get that, but that sort of definition means that ambiguities can still be very interesting. You just don't know if they're anomalies or not because maybe you didn't have the right set of sensors to be able to tell, oh, that
Exactly,
wasn't, ball lightning or something. So you
exactly.
did get some interesting ambiguities. Tell us about those.
So our number one most interesting ambiguity that's almost an anomaly. It's pretty. It's kind of statistically significant. It's kind of a gray area statistically. And none of the prosaic explanations are perfect, although some are close, especially with recent data we took, like, Mick West style, except, he's got his garage and we've actually got a real lab, a scientific lab. So like in the style of Mick West, we were trying to mock up, replicate our most famous ambiguity, which was a dark spot that we observed around 4 a.m. During the week of the expedition.
How did you observe it? What did you see it through? How many people? What were the conditions?
But no people. We only found it many months later because, unfortunately, our original plan of like somebody awake 24/7 and have shifts, that all fell apart. Because when you're filming, everybody wants to be in the movie, right? So then you're only filming a certain set of hours, and then everyone's exhausted, has to sleep. So we ended up having day and night instead of having like a nighttime, like night shift people. I drew up this beautiful chart and sent it to Gary, and we never used it because, again, it just didn't work with the film crew. So 0 people observed this ambiguity / potential anomaly. Unfortunately, it was discovered months later, and it was observed in the UFODAP camera. And again, only one camera, which is a huge bummer, because if we had this in, let's say, we could have declared this, and statistically, rigorously speaking, we could have called this an anomaly if, let's say, one of the FLIR cameras also caught like a break in the clouds. That's what it looks like, at the same time from another angle. The FLIR cameras were all down. And again, we were really excited actually initially. Oh, the FLIR cameras were down because of, the whole woo-woo aspect of, UFOs shut off stuff. No, it turns out we just plugged too much crap in, and, in a circuit breaker. So, and then originally I thought, wow, look, there was one FLIR camera working, and it goes down 10 minutes before the ambiguity. I'm like, oh, that's got to be connected. Turns out that's coincidence. It's because that's when the battery ran out, because one FLIR camera had a battery backup, and so it wasn't affected by the circuit breaker tripping. And as a result, that kept going. But the shutdown or the circuit breaker tripping was like 10 p.m. It was nowhere near 4 a.m., so it's not clearly unrelated. And so we have to be careful. We thought originally we had this great, awesome event that also had like, oh, it shut down the cameras. Oh my God, it must be the phenomenon. Unfortunately, that turned out to be the case later. So that's one of the reasons why we can't call this ambiguity an anomaly, is we don't have confirmation from a second camera, at least, either same type or different type of camera like FLIR, that says this was something in the sky and not an artifact, like in the planet. And so that's why it has to remain an ambiguity, and we can't say this is anomalous for sure. It's just a dark spot that sometimes has a white, bright, pixel speckling. Yeah.
Just a single spot. Dark spot.
A single dark spot, yeah. Which in one of our videos, our most famous video of it, it seems to close or disappear over a course of several frames, and then these white speckles remain.
Oh, interesting. Okay. So what can you say about what it could be? Like, what's the range of possible prosaic explanations?
Well, it's a very broad range. It's all covered in our paper, but there's, a fall streak hole cloud. There is a fly. There is, meteors. There's cosmic ray shower. There's black ops military. How are you supposed to rule that out, right? So we tried to be comprehensive. A star field. It's just stars through an ordinary hole in the clouds. It's a flock of seagulls. That's a classic, one. So, and we tried in our paper to be as quantitative as possible. Oh, water droplet. That's one I forgot. It's not that, because it disappears too quickly. So it couldn't be a water droplet evaporating. We ruled that one out. It's similar, very, very similar qualitative. But when we almost concluded that was a viable option, but it just disappears too quickly to be reached.
So what do you think if you had to bet money, what would you say that you thought this was?
I think best guess right now is a fly that sat on the lens and took off. This is not a perfect explanation by any means, and we're updating our paper to talk more about this with an appendix of additional testing we've done. It still doesn't fit all the facts. Like, it doesn't explain the white dots. I mean, they could be Cameranoids. So the black spot could be a fly, and then the white dots are Cameranoids created by the dark spot, which was in turn created by the fly. But then why don't the white dots follow the expected quantitative behavior of traditional Cameranoids? But that can also be explained. And so it's a string of things. And so you have to multiply the string, together of improbabilities. But basically, there could be this one prosaic explanation of some sort of insect that's sitting there for some time and takes off, but it doesn't explain why it only produces white dots. Sometimes as some type of Cameranoids, but not always. So it doesn't fit all of the facts, but it fits most of the facts enough to convince someone who's already enough to convince, for example, a skeptic or debunker, more accurately, who's convinced that UFOs are not important, not interesting, and not worth studying, would already be convinced, even though I just said it fits most of the facts, but not all.
I'm kind of curious in the degree to which it really does fit the facts. Do we have like recorded evidence and like explanations of how flies would create a dark spot and white spots? Is that something that's been documented before, and why you would get that particular effect?
Yes, it has not been documented before, but it has been now, because when we update our paper in a few weeks or a couple of months, maybe when we, as we go through scientific peer review, we're going to put out a new version of the paper, but it's not just going to have corrections, it'll also have additions because of how much time has passed. So we've also done additional testing, which we hope to include, see if we've got to see if, reviewer and editor agree, but we want to add some more information, and we want to add information on some of the additional testing we've done, which included, we literally like printed out. I've been saying for years that we were eventually going to do this when I've given talks like at SCU conferences on UAPx. We literally like printed out a picture of a fly and I like made a black Sharpie on it to make it really black, and I cut it out, put it on the camera, and we blew it off, and we replicated the dark spot and we replicated the white dot.
But that's using a picture of a fly. And that's significantly different, right? Why don't we just actually get some flies?
I would love to, but I haven't yet. Yeah, eventually. Like what I wanted to do is buy one of those. Well, my colleagues thought this was good enough with the paper. Yeah, I disagree with you actually that they're significantly different. Not really. If you have an autofocus object right on the lens, it kind of doesn't matter.
Well, then why don't you make it a fly then? Why didn't you? Was that just to be funny?
That was just to be funny.
Okay.
Yeah. No, we were just trying to
fly. I want the real.
I know. I do still want to take I want to at least find a dead fly, or at least buy like a rubber fly that's like the correct size and shape and put that on. But no, I think, again, because it's not an anomaly, it's an ambiguity, we need to ask ourselves if it's worth the time. Remember, we're all volunteers. So we're probably not going to do a real fly test, because at this point, I think we've collected enough information to say, okay, it's probably a fly. It's time to look to the future, new data analyses and new expeditions, and not constantly reanalyze the poor quality few frames we have of something that may be some huge discovery, or it's probably just a fly. You know what I mean? It's all about time, investment of time. And with an ambiguity versus an anomaly, the difference is if something's not an ambiguity, you don't waste any time on it. If it's an ambiguity but not an anomaly, you spend some time on it, but you eventually have to decide what's diminishing returns. If something's a genuine anomaly, you keep going. So if this was statistically an anomaly, we'd keep pushing. And you bet your butt we'd go grab a dead fly and do this again, or grab a plastic fly. But because it's in the gray area, we have to ask ourselves if it's worth continuing to do more of these tests.
Okay, let's talk about one theoretical question about this ambiguity thing before we go on to this other paper that you sent me. The theoretical question that I'm going to pose at the end of this sort of ambiguity anomaly distinction discussion is, it seems that whatever the truly anomalous UAP are, they have a lot of options for how to manifest or appear. I mean, they have lots of different shapes, and some of them seem to be able to move in crazy ways, or change their geometry or their sort of reflective properties or whatever. if that's the case, why wouldn't these things prefer to just manifest in ways that would always be detected as ambiguities?
You're assuming there that we're dealing with an intelligence.
I
So
am. Yeah, that's a presumption.
yeah, okay. Um,
Because they seem designed, and that seems to
but
imply not only
is
intelligence, but some sort of complex
that's
intentionality.
almost the case, right? There are very few genuine anomalies because most of the time people just say, "Oh, one blurry image, no one can scoff." So actually, I think that's already the case. And so I think we are in that situation. But I think that also, if we are dealing with an intelligence, maybe, again, this is wild speculation. What if it's a test? To see, are we smart enough to figure it out that some of the ambiguities are anomalies? So I think there are potential rational explanations for that.
I was talking to Gary Nolan recently, and he makes this exact point that he thinks that there is an element in which these are a kind of intelligence test. Like
Yeah, exactly.
at some point, we'll be able to detect them for whatever they are, or for at least more than just prosaic objects, but we're generally, as a whole, not there yet. Um,
Hmm. Hmm.
okay, so you sent me a second paper that I thought was a lot of fun and that I want to recommend the listeners to check out too and to send to people who they think might have some interest in this. Because what you do in this other paper is you take like just the list of objections to seriously studying UAP and kind of go point by point and give your answers as to why this is a serious topic worthy of the consideration of serious people. And you give like a dozen of them, and we definitely aren't going to go through all those. I want to leave good reading for the audience, but I do want to focus on a few of those that I thought you gave particularly insightful answers to and let you kind of flesh those out. So, first of all, what objection to UAP as a subject do you encounter the most and are most annoyed by?
That's an excellent question. But first, I should stress it's not really a paper; it's just an essay. So it's not a scientific paper.
Sure,
It's
yeah,
never
not journal.
yeah, yeah, it's not a journal. It's never peer reviewed. It's just me writing on the internet for fun. So it's like the equivalent of a blog post. It was a Medium essay originally, and now it can just be found on the UAPx website. So it has references though. So I do try to make it at least serious and rigorous. It's not just me talking out of my butt. It's got like 200 references in the bibliography, but many of the references are not scholarly sources. There'll be other
Sure,
websites.
yeah.
But yeah, the number one that I always encounter is kind of a two-parter, but intimately connected. It's making the a presumption that UFO equals alien, and then jumping to saying that interstellar travel is impossible. That's the one I always encounter, and that I spend a lot of time on in my essay because, again, the extraterrestrial hypothesis is one of my favorites for good reason. I do think it has a favor of it, but not proof. But it does have good evidence, and I do try to tackle the interstellar travel question. I get super attacked on that by people who claim that interstellar travel is impossible and will always be impossible for any.
Yeah, the argument there is that we'll leave the UAP or aliens assumption aside because we've already covered that. And but the ET hypothesis is worth consideration. It's the most popular as
Mhm.
far as I can tell. Um, but this other sort of objection that, well, if they're ETs, they would have to travel so far that it would just be prohibitively resource uh, costly and or faster than light travel isn't possible, so they, would all be dead before they got here, right? That's the kind of
Right.
argument that you're talking about. And why do you think that? I think that's a bad argument too, at least if it's taken to conclude that therefore, they would never undertake such a journey. But why do you think it's a bad argument?
Is a horrible argument because it forgets things like, and scientists will make this argument. It's almost like they forgot basic physics that they teach or they learn, in their whole careers. But it doesn't take into account relativistic time dilation and length contraction. So no, distances aren't that great, not for the traveler, and the times are not that great at all. You could have aliens with a lifespan shorter than humans that are still exploring the galaxy, and it's not a problem. And you don't need faster than light. That's irrelevant because of the time dilation and length contraction in special relativity. So actually, faster than light travel need not apply. It's completely unnecessary for exploring the universe. And it's a very common, shockingly common logical fallacy that I see everywhere all the time. And it's made by scientists and engineers even. Oh, it's too far. Oh, the time is too long. False and false on both counts. Now, then, whenever I point this out, then the next step of argumentation is, oh, but the fuel requirements are so vast and shielding. And I don't have an answer to that. But I do have historical examples where we used to think space travel in general, even local traveling a low Earth orbit and going to the moon, was completely impossible and would never happen. That humanity would literally never figure it out. We used to say the same thing about air travel. And I see the same arguments trotted out, almost the same, but they're updated, obviously, for outer space. But there's similar arguments made for why interstellar travel will be impossible. Sure, fuel is a problem. Sure, shielding is a problem. Neither of those problems are problems of physics.
Those are engineering problems.
Engineering. And then I'm accused of blithely, what is it that they said on McWest's website about me? I blithely assume that engineering will figure it out. I've got historical examples of that. Air travel, space travel by humans. Like, yes, we have figured out difficult problems. And I'm not blithely assuming that we would do so as humans in 10 or 50 or even 100 years or even 1,000. But I think it's extremely naive to claim that in a galaxy that's several billion years old, in a universe that's 13.8 billion years old, I think it's extremely naive to claim that no civilization ever, even one that exists potentially for millions or billions of years longer than us, none of them will have figured this out by now. Really? That's a pretty big leap for me, I think. To me, that's an extraordinary leap to make, to claim that because we'll never figure out a proper fuel or propellant to be able to achieve relativistic travel, and we'll never be able to develop materials that can shield against radiation at high speed. Because remember that starlight is fatal when you're traveling relativistically because of Doppler blue shift. So there are serious problems to overcome, and I do acknowledge that. But I never claim, I've also been accused of, oh, I have this faith that technology will cure everything. No, but I do have a reasonable, logical, rational claim that given thousands, millions, or billions of years, yes, technology will eventually, given enough time, will solve the problems the same way that natural selection, through, how evolution solved problems in the natural world through natural selection to produce, sentience, intelligence, and different skill sets for different animals and different types of organisms. I do think that that technology evolved also, and that given this astronomical timescale of billions of years, where you might have civilizations out there that predate human civilization by a mind-bogglingly large amount of time compared to how long humans have existed and compared to how long humans have had technology. So I call relativistic travel a solvable problem, not saying that blithely, not putting a blind faith in technology, but just saying that if you multiply those difficulties and improbabilities by a massive amount of time, I think it's reasonable to claim the engineering hurdles would be solved by an advanced civilization, then figure out the fuel and the shielding needed to achieve relativistic travel. And even if they don't, who cares? Then maybe it's like Avi Loeb suggests, what if the probes are sent out like we've done, like Voyager, that travel for hundreds of thousands of years? And again, the galaxy is billions of years old. What if, okay, relativistic travel is impossible? Fine, the skeptics still lose the argument because you can have probes that have been traveling. You could have probes that aren't necessarily with any organics in them, that are just machine probes like humans have created, that travel between star systems for hundreds of thousands of years at pathetically slow speed. So there's always that fallback position that Avi Loeb is always stressing. It's astroarchaeology, right? Or archeo, the forget the term that we've created for that. But basically, and that's not a new idea either. So no matter what, I've got a counter argument for that. So even if I'm wrong on argument number one, I have a backup for that one and a backup to the backup that goes and says, like, it is very reasonable to expect technology to make it across space, because there are all of these reasons why that would be a rational assumption to make, that if intelligent civilizations exist, they would have some sort of travel capability far beyond what humans have.
Yeah, and the I agree with you, and I think a way of putting in very simple terms the reason I fundamentally agree with you is that it seems to me that the burden of proof is on people who want to say that something could never ever be
Mm-hmm.
done, right? To say that something is not within the realm of possibility is an extremely strong claim. Nobody's claiming that every person or every race or every planet has a life on it that's doing, interstellar travel. But to say that it's a sort of theoretically, physically insurmountable problem is a claim that nobody is even really making. I mean, so
Well, no, it is being made on at Metabunk on Mick
oh,
West's
but
website.
not serious people. No serious people are making. I mean, people on a forum can make whatever
Yeah.
claim that they want, but no person who actually knows enough physics to capably handle these conversations.
No, but there are scientists who should know better who are making these claims.
Yeah,
So Neil deGrasse Tyson has made this claim repeatedly, and I have found this claim in real published, written, not just YouTube videos, but written scientific papers make the claim that not only is interstellar travel impossible for humans and any non-human intelligences, it's impossible today and will always be impossible. That is a shockingly strong statement for me.
yeah, I
For
can't
me,
understand that. I mean,
I for me, I count on the fingers of one hand the thing that I legitimately think are impossible, and I humbly admit that some of them might turn out to be possible. But I just can't understand people who claim that we supposedly know so much physics already and so much science. We know so much about the universe that we can make these claims when we don't understand 95% of the universe. We don't understand what dark energy is, what dark matter is, and that's just the known unknown. What about the
yeah,
unknown?
there's a lot of unknown unknowns.
Yeah.
A
And
lot of
so I think it's the height of hubris to claim that people think that I'm the one with the hubris that, oh, humans will eventually solve space travel. No, I humbly admit that it'll probably take centuries. I'm not claiming that by 2000, that mid 21st century we'll have warp drive like in the Star Trek timeline. I'm not claiming it's easy. It's very, very hard. I'm sure it's very, very hard to solve the fuel and the shielding problems. But I'm not convinced that even after billions of years elapse and a civilization survives that long, survives wars and pandemics, that they wouldn't figure it out. I think they would eventually.
We need
So,
to disentangle two different questions here. One is the question of whether true faster than light travel is possible, which is
yes,
something a lot of people get hung up on. The question of
correct.
whether you can actually exceed accelerations beyond the speed of light. That's one question. But then the question of whether interstellar travel is possible is a completely different question. We can leave aside the question for the rest of our discussion of whether exceeding the speed of light as a speed limit is even possible. Let's just assume that we'll never actually get to accelerate through space faster than that, or that we'll never be able to like bend or warp space time in some way that kind of gets around the speed of light as a fundamental speed limit.
As a cheat.
Let's focus on the idea that we'll always go somewhere below the speed of light. You point out in one of these sections of the essay that if you just accelerate through space at 1 g, that's 9.8 meters a second squared, the rate at which objects fall off your table. If
Yeah,
you
very
uh,
comfortable, right? Yeah.
yeah, it's totally survivable. I think humans can survive like up to 10 or 11 Gs or something before it kills them. But if you just stayed at 1 g, if you could maintain that acceleration through empty space, you would be at about the speed of light at the end of a year.
Yeah, roughly 2 or 3 years. And it also, yeah, it depends what you mean by about, because you'll always keep
You'll
increasing in
never
speed.
actually, yeah.
You'll never hit the speed of light, and you'll just get to 99%, 99.9%, et cetera, et cetera. But yes, this has been known for over 100 years, and I point this out in my essay. And again, the criticism is, what about fuel? Oh, it would take astronomical amounts of fuel. Ironically, when they point out that I skip over the fuel and the shielding, and they think that's because I don't have an answer to that. I skipped over it because the essay was already too long and people were complaining that it's too long, not because I didn't have answers, but my answers would be, as I said earlier, highly speculative, because we don't have an answer for the fuel requirement for it, or the shielding. But my point is there's nothing against the known laws of physics that would prevent this. It's only a question of clever engineering. And I point to history, to human history, for examples of how engineers are always overcoming these problems. And yes, I know this is a much worse problem than the historical examples, but we're also improving our technology, every year, every decade, every century, as human.
Yeah, well, and this is again, it's helpful to distinguish between this sort of problem and the problem of traveling faster than the speed of light. What you're saying is that our current models of physics don't tell us that this is an absolute impossibility, right?
No, it's the opposite. It's a guaranteed possibility. We do it every day. The particles in the Large Hadron Collider, muons in cosmic rays, live longer than they should because of time dilation. So time dilation and length contraction and relativity are not under question, except by crackpots.
I mean, the fuel problem and the shielding problem. There's nothing in our models of physics that tell us we could not engineer a fuel or a propulsion and shielding mechanism that would make this possible.
That's correct. So basically, it would be very, very difficult. We don't have a practical, easy solution that we currently know of, but there's nothing in the laws of physics that say we wouldn't be able to figure this out eventually for sublight travel.
The way there is something in our current models of physics that say you're never going to be able to cleverly engineer a way to really accelerate through space faster than the speed of light.
Well, the funny thing is you could get that too. It's more speculative, and I could give you like 15 publications about how you go faster than light. But the reason why I don't like going there is because it's unnecessary. So what's beautiful is, like you said earlier, it's a two-step approach. Basically, number one, faster than light absolutely might be possible. And I can send you 15, 20 scientific publications that say this from recent years. And going back to, Alcubierre, of course, in the classic seminal paper in the 90s. But then the second, much stronger part of my argument is that number one isn't necessary. That let's give the critics, give the skeptics, yes, faster light travel is impossible and always will be. I'm willing to grant that, even though I can send you 24 scientific papers that say actually maybe through warping of space-time with negative energy, we could figure it out someday. I'm willing to grant FTL and warp drive is impossible. And then I fall back on the fact that using known effects, relativistic time dilation, we don't need FTL. It's a distraction. It's sort of like a red herring, or maybe straw man is the more accurate term. Yeah, it's a straw man argument. Basically, people come at me and will say, "Oh, we'll never go faster than light." Therefore, and I'm like, but that's a straw man argument, because you don't need to go faster than light for interstellar travel to be possible and to explore the universe. But then again, I have a backup, which is, but it just so happens that faster than light might also be possible. But I try not to go on that tangent too often, because then people forget my main argument, which is you don't need it. Time dilation and length contraction are good enough to get you to explore the farthest reaches of the universe.
So let's talk about how that would work. Let's imagine that we've got some sort of shielding mechanism that means we can move through mostly empty space really, really fast, and we won't hit a single particle of dust, and it just annihilates
and destroy us. Yeah.
And we've got some propulsion system. Let's say it's like a light sail. We've got some hugely powerful set of lasers on Earth that are constantly hitting the back of a ship's sort of sail, the way wind hits a sail in the ocean, and it's pushing it and it's accelerating it at like a G or something comfortable and totally, within our current technological abilities. you start getting really fast around a year, and then time starts getting funky. So
Yes.
we can get really close to the speed of light that way. And from the perspective here on Earth, how long would it take this proposed ship that we've got to get to another star or another galaxy?
That's a great question. So let's talk about the closest stars, Alpha and Proxima Centauri. And it would take about, I believe it's 4 to 5 years. That's from the perspective of people on Earth. If we're talking about probes with people on them, because they could be, unmanned probes, which is actually planned. But let's say that there is either human being or another, intelligence aboard this, then depending on how fast you're going, the time is arbitrarily small. It depends how fast you're going. There's no one answer. Are you going 99, 99.9, 99.999? There's a big difference. I'm not talking about a small difference. To the person doing the traveling, those roughly 4.5 years or something like that to the nearest star close to light speed could be 1 year, could be a month, could be a week, it could be a day. I'm not exaggerating. That's an arbitrarily small amount of time.
It depends on how
fast you're going.
Yeah.
Because the faster you go, the more time dilation you experience. So to the next galaxy, it's more dramatic. Let's say we want to send something to the Andromeda Galaxy. 2 million years would have elapsed on Earth. But for you, maybe it's 50 years, maybe it's 10 years. It all depends how fast you're going. So a homework problem I like to give my students in Physics 3. So this is not a freshman problem. People like to make jokes about freshman physics problem. This is a sophomore physics problem, to be more precise. This is a sophomore or junior problem, or advanced freshman who's doing special relativity already in their first year with classical mechanics. But basically, I ask, how long did it take to reach the Andromeda Galaxy? And invariably, students say, 2 million years, 2 million light years away. That's only in Earth's time frame. But if you travel 0.06 meters per second slower, not faster, slower than the speed of light, you make it there in 50 Earth years, which blows people's minds. And then I'm always shocked when people's minds are blown, especially in the UAP field. I'm like, this isn't new. We've known this since 1905. This is basic Einstein theory of relativity.
Yeah.
And it's not, and we know it's correct. We have mountains of evidence going back a century. We know relativity is correct from, I mentioned earlier, particles in the LHC, cosmic ray particles living longer than they nominally should. We know relativistic time dilation is correct and is real. We just don't have the engineering to be able to do it with humans yet. But we do it with subatomic particles on a daily basis. So and it was proven with atomic clocks in the 1970s, the famous Heffel and Keating experiment. So we know relativity is correct. So what I just stated is not some crazy hypothetical speculative thing. It is period, end of story, correct and true. If we could get over the fuel and shielding issues, which I mentioned earlier are serious issues that we can't just sweep under the rug. They are serious issues. But if we overcame those issues, you can reach the Andromeda Galaxy without warp drive. You don't need faster than light travel, and you can get there in one human lifetime by going slower than the speed of light. And then people always point out, well, everybody would be dead back on Earth. So,
yeah.
I mean, there are examples of nomadic populations. We have the Pacific Islanders on Earth. This is my colleague Kevin Knuth always brings this up. What's wrong with being nomadic? There are tons of people who would sign up for this. People say, who would agree to do this? Are you kidding me? I would be one of the first to sign up to leave Earth forever and explore the universe. Are you kidding me? And people are shocked always at how many people sign up to go to Mars before, we've even figured out all the safety, issues yet. I think also we are also anthropomorphizing. There could be species out there that have an even greater spirit of curiosity and exploration than humans do, but we don't even have to go there and argue about anthropomorphization, because humans, we can just look to examples of humans with our curiosity. Hell yeah, we'd have people who would say, oh yeah, by the way, millions of years will elapse on Earth for you in the next 10 years. I don't care. That's awesome. Let's go tomorrow. And so I think that that's not a problem, is not having a home planet and being nomadic. It's not a problem if you've solved the fuel and the shielding, because honestly, if you've solved the fuel and the shielding, you should be able to solve food and basic needs as well should not be, I imagine, as difficult as the problems of fuel and shielding. Especially if you solve the fuel and the shielding, then you can shrink the journey to such a small number of years across vast distances that it reduces automatically the other problems like food and drink and things like that for the journey.
So this means that minus the shielding and the fuel issues, which are engineering problems, this is within our grasp. There are even projects right now, like the Copernicus project, that are trying to make the first von Neumann probes that will do something exactly like this. They'll accelerate them out of our star system and to other places where they can start self-replicating or studying things, right? This is
Exactly.
like, I know that sounds
Exactly.
crazy, but that's the state of our
No,
current.
but we don't even need to go that far. There's also another project to send probes to Alpha Centauri by the 2060s, and the idea is to have a swarm of miniature ships. And so these would just be, robotic probes, but tiny ones with just like a camera or something. And so this overcomes both the fuel and the shielding, by the way. So this is already within our grasp, not with humans aboard, but that's okay. Not with any beings aboard, but this is already within our grasp. That's why I get so angry at skeptics who say interstellar travel is impossible. We're on the cusp already in the 21st century because we're already planning on trying to do this, where this is the way we have cleverly already thought of workarounds of the fuel and shielding problems. Number one, fuel, no fuel. You just shoot high-powered lasers. So this is within our grasp already, or only decades away. We'll still need to create the array of lasers and prove it works, but this is not a big stretch from current technology, not at all. You would basically fire high-powered lasers at tiny ships and get them up to the speed of light very quickly. So they have no fuel, no propellant. They're just light sails and lasers. Check. What about shielding? We've solved that too. Already. It's a cop-out. You just make 100 or 200 ships. So most of them are not going to make it because they're going to hit a piece of dust and just blow up near the speed of light. So we did a cop-out. Because we don't have a solution for shielding, the cop-out is, well, just make a lot of ships and most of them will get destroyed on the way. Oh, well, just make a lot of small, inexpensive ones. So this is, I believe it's called Starshot. I don't remember the name. I think Avi Loeb is also in charge of this or chairing this. There is this project already exists and has for several years, this idea of just making a swarm of ships with little cameras and go take a picture of Alpha Centauri. And this is already, as I said, very close to what we can achieve today. A little bit more money and a little more engineering, we should be able to create this swarm of nano ships or microships. And so I think that it's disingenuous to claim that we have no solutions to the fuel and the engineering problem. We already have several. And I got so aggravated when on the Metabunk forums, they said, oh, Szydagis skipped over the fuel and the shielding. That's because the essay was already really long. So I'm going to write a part 2 eventually. I just don't have the time. And I'm going to debunk all of the debunkers' arguments against my first essay. And I'm going to point by point and circle their entries from the forum, quote them, and say, yeah, you want me to address fuel and shielding? Boom, 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 boom. Here we go. Here are my points. But my biggest point will be, I don't have to address fuel and shielding. Give it a few billion years. I mean, I'm not asking people to have faith that we'll have manned probes to Alpha Centauri tomorrow. That's not my claim at all anywhere, but somehow I got roped. People put up these straw man versions of the actual arguments I was making so they could knock them down.
Well, I mean, it's not exactly their fault either. Most of these people don't have PhDs and
exactly, they're not actually scientists, which is funny because most of the debunking is being done by non-scientists.
So last question that I wanted to hit you with from that one article is has to do with the reverse engineering question. So you say that one thing that annoys you is this question about, like, if we have crashed parts or in any sort of retrieved technology, why haven't we reverse engineered them and like revolutionized the world? I myself am skeptical of even the possibility of reverse engineering alien technology. I think that the nature of technologies are that they're not just objects, they're systems. If I
Hmm.
gave an iPhone to Leonardo da Vinci, as brilliant as he was, or Isaac Newton, who was miraculously intelligent, it's
Yes.
not they wouldn't be able to get anywhere with it. It's not because they aren't smart enough. It's partially because they don't have the concepts they need to understand what the technology is doing. I mean, you need to know what an electron is. Um, Another problem, though, is that an iPhone works through a system of technologies. It's useless without chargers and a power system and satellites,
Exactly.
GPS, all these other things, servers and software and stuff. So it would just be a brick. It would be a kind of a nice geometrical object that wouldn't do anything then. And reverse engineering would just not get us anywhere. So why should we even think that reverse engineering is possible if we did retrieve anything? But if it is possible, why haven't we like revolutionized the world if there have been crashed, pieces
Well,
of
it's
humanity?
it's 2 points. It's a 2 point answer because first, I am also skeptical, even though I've talked to people like Eric Davis. I'm friends with Eric, and we've all watched David Grush talk about reverse engineering programs. But to me, I'm still skeptical because then again, where's the evidence? Show me a ship, show me a body. Of course, it's always classified as the answer. But then there's a second layer, which is let's, for the sake of argument, say it's true. And Grush is telling the truth, and Eric Davis is telling the truth. Let's say that for the sake of argument. Then I agree with your examples. I gave one just like that in my essay. That's probably why you gave the iPhone example. The example in my essay was give your laptop to someone more recent even. Take your laptop and give it to
It was like Richard Feynman or somebody, or
no, he was a theorist. He is not a good example. Albert Einstein also, most people don't realize he was a theorist. So everyone wants to give the laptop to Einstein. I'm like, do you realize he was a theoretical physicist, not experimental?
Faraday. Then
Faraday is always my good example. The one of the greatest, like Maxwell, one of the biggest names in electromagnetism. A laptop runs on electricity. He should figure it out, right? Are you kidding me? Especially after the battery runs out and he doesn't have anywhere to plug in the charger. If he's got that, he's not going to know what the hell that's for. They would think that it's just a magical screen that suddenly goes black one day, right? Because the battery runs out.
After like
They
5
would make
hours.
no progress. They would make no progress. And what's remarkable about this example is I think you don't need to go. I really don't like the examples of like, let's give an iPhone to Aristotle. That's too extreme. And I think that we don't need to go that extreme. Avi Loeb gives the example of give a cell phone to a caveman. And I'm like, no. Stop right there. We don't have to go back that far in time. Literally just go to the 1890s. Take a MacBook Pro, take a Dell PC and give it to someone in the 1890s, and it makes the point, I think, more effective. Because look at the gap of only what? A century and a half is enough to make people clueless about how the technology works. Now, we could argue, and I don't know where's the cutoff. If we gave a laptop to scientists in the 40s, would they be able to figure out the 1950s? I don't know the answer to that. Nobody knows the answer to that. But I do think there's a cutoff somewhere. Like I'm sure by the 1980s, oh yeah, hell yeah. If a time traveler gave your laptop to someone in the 1980s, they would have better laptops for today. Like I know that there's at some point where we'll figure it out quickly. But I think that it's not that far back in time where people would be completely clueless. Like the brightest, if you took 100 of the brightest scientists and engineers, 100 of them, and put them on figure out what the hell this MacBook Pro is, they'd make no progress, in my opinion.
Yeah, I think we can draw specific lines and explain why. Like, if you don't have a microscope good enough to look at a chip that's had like nanoscale structures etched into it, you can't figure out what the hell it does. It just looks like a thing. So you actually need specific technologies and specific theories in order to do the observation and interpretation. But keep going.
That's right, but it's worse than that. Because let's say you have all the microscopes to see all the pieces of the laptop. You still don't know what the hell it does. You still don't know what it's for. It depends again where we drop it off back in time. If you don't even have microchips or transistors invented yet, you don't have a clue. And so even if you have the proper tools to do a diagnostic on what the materials are and what their spatial arrangements are, you're still a far cry from understanding the purpose. And so that's why I think that even if reverse engineering programs exist, even if they do exist, and again, I'm leaning more and more every day towards yes because of Rush, because of being friends with Eric Davis. So I'm leaning more and more and more towards yes, but I think they're not making any progress, and I think they're doomed to make no progress. The reason is because I just gave you an example of 100 years. Imagine if you've got something that's billions of years more advanced. We wouldn't know what the hell anything was for, even if we have electron microscopy and we've got, isotopic analysis so we can figure out exactly what something's made of, exactly what the spatial arrangement is. We still might be clueless on the purpose.
Yeah. So, atom for atom, we could understand it.
Yeah.
What the
hell does it do? What's it do? And so I think that that's a serious problem that my laptop example illustrates, because it only takes a few decades of removal from a technology, a gap in time, to show that it would be impossible. And you mentioned systems. Systems are the other thing that make it impossible. Once the charger stopped working, you'd make even less progress, because now you can't even turn the damn thing on. So unless you figured out what the charger is and what it's for, you would make even less progress. And that would be true of any alleged crashed parts from non-human intelligence. How do we know how to power it? How do we know how to turn it on or keep it on? We probably don't. And so that's another layer where, yes, when it's off and dead, we could figure out what it's made of maybe. But what does that tell you about how it works when it's on? So even if we have reverse engineering programs of some sort of non-human intelligence, hell, I am super skeptical we'd ever figure anything from anything, because it would just be too hard. And people who've allegedly actually worked on these things have privately admitted that. So Kevin Knuth, maybe he said this during the episode you had with him, he asked Hal Puthoff about this, or he had a comment about, I think, everyone's talking about metamaterials for propulsion. I think it's actually the computer. And Hal looks at Kevin and says, Kevin, we would know the difference between the computer, the navigational computer, and a sandwich. And so that's why I'm more likely to believe people who claim they were part of crash retrieval programs if they claim we don't know anything. Like, yeah, that sounds about right. And I'm very skeptical of people who claim, oh, yeah, we figured it all out and it's element 115. And just, I'm like,
yeah,
we didn't figure it out.
I totally agree. And I don't know what our norms are going to be about naming names, but like, in my view, Bob Lazar, who's gotten maybe the most attention up until
and Bob Lazar is full of shit. And I've said that on the record on multiple YouTube videos. He's provably full of shit. Like, this is not a gut feeling from me. No. He's provably full of shit. Everything he says is wrong. Now, I don't doubt, again, like I said, I'm willing to allow for the existence of a crash retrieval program and a reverse engineering program. But we don't know how it works, or we've made very minimal progress on how their stuff works, whoever they are. Again, not limiting to extraterrestrial, being much more open-minded. I think that I'm very skeptical we've made any progress in understanding how it all works.
And if we did, if we found it in the sort of Bob Lazar fantasy story, we find a ship and we just know how to open it up and start moving it around, the thing we should assume is that this was either made by humans or made by something that's extremely human-like, that's been here and using the same technologies as us. This is not like a totally alien group. Because, I mean, just like your morphology, your physiology, and your senses and things. Like, even to understand, like, when you talk about giving a laptop to Michael Faraday, what if you gave it to a species of beings that don't use visible light to see things?
There you go. Then they don't see the screen. Yeah. What if you gave the laptop to a species that only sees an infrared because of the type of star they orbit and type of sunlight they get? That's a perfect example. Or ultraviolet, to pick something. And to them, the screen is blank and they have no clue what's wrong with this laptop computer. It doesn't show it. It's supposed to display stuff. That's a perfect example that anything we would attempt to reverse engineer, what if it's something beyond our sensors? What if there are keyboards, dials, and switches that are there but are invisible? The human eye and human touch, but they're obvious to a member of that race,
Sure.
you know? And so, yeah, I totally agree. And I think that if there is some kind of program, it's doomed to be a waste of taxpayer dollars, which is one of Grush's points, is the money, the black money. It's just a waste of taxpayer dollars because we're never going to figure out how that works.
We might be able to do like interesting materials analysis on it,
Yeah,
which is like the sort of
definitely.
stuff that
Yeah.
Gary Nolan does.
Gary, yeah,
That
Gary's
piece of stuff, and
yeah.
that's super interesting. How the way
It
we've
is.
got
It
layers
is.
of heavy.
I think that if crashes are real, again, I'm kind of on the fence still, but if they are, then I think while they might not be usable for reverse engineering of particular cool applications like anti-gravity levitation, or whatever, they could be used to provide definitive evidence of non-human intelligence by saying, look at these crazy arrangements of atoms that we don't know how to do and isotopic ratios and stuff. So I do think that unclassified versions of things could be used to just definitively state, look, people, there's something going on. There's like a non-human intelligence, and they build stuff, and we don't know how it works. So I do think the isotopic analysis things like that can be helpful. They're not necessarily going to clue us in though on how these things work.
No, but they could also give us good ideas for our own applications, like the piece of weird material that Gary Nolan looked
Yes.
at has all these sort of like almost nano layers of really heavy isotopes, and I think that the initial question was like, how could you even manufacture this? And then a while later we think, oh well, you could manufacture this if you did it in microgravity, because layering these various weights wouldn't affect each other. The relative weights wouldn't affect each other. And now we have satellites in orbit that are doing microgravity manufacturing of drugs that then get shipped down in little pods that are now people are taking drugs they don't even know are manufactured in space. And there might be a historical story to be told about how that idea and application was derived actually from analyzing what may be a piece of a crashed UAP. We don't know. So it's scientifically valuable, but not in the straightforward like sci-fi kind of way that we all assume, which is a bummer because that would be a lot more fun if we could just like figure out a spaceship and then go wherever we wanted. But
yeah, I mean, we can't even figure out USB versus USB-C. How are we going to figure out?
Yeah, for real.
It's so aggravating. All the airports have USB now, and it's like, oh, just kidding, guys. Now it's USB-C. I'm like, you're kidding me. We changed it again. What's the one constant about universal serial bus USB? The one constant about it is that it's not universal. There's this shape and that shape, and like, how would we connect? What ports would we connect to on an alien spacecraft? We will be clueless. And so I do think that if there are these parts, again, if Gary has these, man, I want him to invite me to visit. I want to see some of this stuff. We've got to get the evidence out there and convince more people in the mainstream scientific community that there is evidence. But again, going back to the very beginning of our conversation, I want to take things step by step, and I don't want to jump to the conclusion, non-human intelligence and physical craft. I want to start by taking data on what's in the sky and get evidence of UAP in the sky. But all of these different avenues of research are equally valuable, and I do think that hypotheses like extraterrestrial, interdimensional, and all these non-human intelligences, these hypotheses are worth having on the table, but not at the expense of other possibilities. Like,
no, and it's not a competition between them. Like we can pursue many different research agendas at the same exact time. I think that's why it's so exciting that groups like UAPx and SCU and the Sol Foundation, the Galileo Project all exist, and we're still trying to kind of like figure out the landscape of what we all do and like what our corners of research are and how to like coordinate among each other. But it's really a good thing that we're all taking like very different approaches to how to study this and think about this very strange world that we're in. Matthew, thank you so much for being here. This was a fantastic conversation. The Anomalous Review is a project of the Scientific Coalition for UAP Studies. It's hosted and produced by me, Michael Glosson, and edited by Kelly Michelle. Our theme song was written and performed by Telma Crisanti. Communication and PR work is by Preston Dykes. Our advisory team includes Jennifer Roach, Robert Powell, Richard Hoffman, Joshua Pearson, and Larry Hancock. To find out more about SCU, check out explorescu.org.